Good afternoon. I know it's been a long day. And when I was the last speaker, I realized probably most of you are overloaded with content. What I'll try to do is, when I was trying to prepare for this, there are posters that follow this session. So what I wanted to do was try to motivate you to go to the posters. So I will try to give you a high-level view of what they've done. It's partly because of the time and partly my competence. It's impossible. As you'll see, there are many people. When I saw Massimo give the talk, I was very impressed. He was willing to actually go into details of everyone's contributions. But what I will do is talk a little about the general problem that they're trying to address, maybe key results, and then ask you to go to the poster to get the details. There are many individuals involved here. First, I want to thank the CWC sponsors, and in particular, Atkinson and Huawei, who have actually decided to support this particular project. There's several faculty members. Professor Cosman is actually the PI. And then there's research staff from Cal IT2 involved in this project. And the funds support a test bed. I'll talk a little about that. And also 3 PhD students. Okay? So let me see. Somehow slides are missing. This is old slides. Doesn't matter. Okay. As you notice in the title, there are two talks, D2D and relay assisted. Okay, so I will start with talking about D2D first, because maybe that's not as familiar to many of you. And then I will go quickly through the relay part, because I think that may be more familiar to you. Okay. So D2D communication is device-to-device communications. Okay? And the idea here is to exploit proximity of devices to get better spatial reuse, okay, on frequency reuse. So you basically imagine device 1 wanting to communicate with device 2 in a typical cellular setup. It will go through the base station. Okay? It's a 2-hop and also much longer distance. Okay? Whereas if you knew they were in proximity, then the base station could hand over and they could directly talk to each other. Okay? So the device-to-device communication is essentially trying to make sure that devices that are in the proximity are now handle the communication on their own. So what are the benefits of doing something like this? The proximity leads to lower power, and potentially higher rates. So if the distances that you have to traverse is shorter, and of course the power consumption is. Of course, hop gain, because there is no two hops involved in a cellular network, the uplink and the downlink. You avoid that. It's a single hop, and so you actually get less delay in such a communication. Okay? And the last one is actually radio resource reuse. Okay? So those frequencies that are being used by the D2D now potentially can be used by the cellular network in other locations. Okay? So you get better frequency reuse by virtue of handing over this to the D2D communication. Okay? So here's the case which makes it look very attractive. Okay? So and this is where we want to head to, is to figure out whether we can make maximal use. Here you have a base station basically does nothing. Okay? It decides that all of you guys don't need my help and just hands over them to carry out their communication. So you have many pairs, okay? And you can see that the same frequencies can be reused by these pairs if they're sufficiently far apart. Okay? And that's really the understanding that if there is such proximity, then there is no reason for them not to communicate directly and get better spectral efficiency. Okay? So what are by the way, in this kind of link sharing, I also want to point out that it is possible that the base station could serve one more user with the same frequency. Okay? So it's conceivable that that frequency could be used by the base station. It doesn't have to be not used by the base station and just simply used by the links. Okay? Of course, the challenges in this are, of course, you have to discover devices are in the neighborhood. So this is a peer discovery process. So we're hoping this will be network assisted. Okay? Then there is the issue of mode selection, that is basically figuring out who should be in the D2D mode and who should be served by the base station. So in the normal mode, so a decision has to be made. Okay? And this decision could be made by some objective criteria. And that's really part of the research part, is figuring out when will the base station decide it is in its interest to allow them to go to D2D mode. Okay? And then, of course, when you go to the D2D mode, you have interference, the usual issues of interference management and coordination. Okay? And so you'll have to deal with interference management in this case. So So just to give you an idea of what kind of interference you may have, so you can imagine here a reuse where the base station is using the same frequencies that the device-to-device are using. Okay? And in this case, the devices are using the uplink frequencies. Okay? You can see when the device 1 communicates to device 2, it causes interference to the base station, which is in uplink communication with this device. Okay? So the green means good, that is the desired link. Red is the interference link. Okay? So you get interference based on this reuse of the same frequency. Okay? I haven't drawn other cells. If you have a multi-cell environment, then you can get interference between cells, so you can have inter-cell interference. And the same thing is true if you decide to use the downlink frequencies for the D2D communication. So you will have interference, and this has to be managed. Okay? So the research topics that the group is addressing basically falls in two categories. One is the system issues. Okay? And this is how do you enable D2D communication? You know, there are many physical layer decisions that have to be made, and so there's synchronization and reference signal design. Okay, and often this is a lot of these are really experimental issues that you have to debug and see feasibility. And if you think they're feasible, then you have to address these. And so there's a test bed to debug and learn some of these experimental issues. On the theory side, you need to know that the devices are sufficiently close to be able to close the link, okay, so before you hand over. Okay, that could be done by channel sounding, but it'd be good to do it beforehand with some prior knowledge. In other words, you already know that the link has a high chance to be closed, and so you can enable it. So channel modeling will play a very important role. So our goal here is really to see if some kind of learning can be incorporated in the system so that the quality of the links can be modeled by some random variable with a conditional distribution. Okay? And lastly, we would like to set up an optimization problem wherein these mode selection, frequency allocations, and the power are done through some global optimization framework. Right? So let me say a few words about the testbed. This is a collaboration with Atkinson. So Atkinson is very deeply involved in this and helped work with Cal IT2 researchers to actually come up with this testbed. And the idea is, of course, to use this testbed to do fast prototyping and verification of ideas. Okay? And for this testbed, we have a warpboard-based platform. Okay? And the UCSD team has been involved in the hardware design and the file layer design. Okay? And Atkinson has collaborated on the I'm assuming that's software, SW, okay, and the Mac layer and the protocols. Okay? And the system is flexible, so you have full access to the entire protocol stack, so you can do all kinds of experimentation with this. Okay? This is a network-assisted D2D implementation, and the implementation that is right now available is a 3-node setup, where there's a radio network node and plus 2 devices. Okay? And it uses a TDMA system. Okay, so the nodes are communicating with each other in a TDMA fashion. So the devices, of course, there's control signaling because remember, this is network assisted, so the network has to hand over and enable this D2D communication. And there's a real-time IP traffic that is transmitted between the devices, okay, once they're enabled. Okay? And you can check the device performance with the help of a GUI. So what they've emulated is a base station with 2 devices. Okay? So the devices initially communicate in the standard way through the base station. The network then decides they're in close proximity, and then it directs them to go towards a direct communication. Okay? This, by the way, there's a demo outside. So at the end of the talk, you can go look at the demo and talk to the people involved. Okay. On the theory side, we are looking at resource sharing. And so in this case, we're trying to set up an optimization problem where we can figure out how to do power control and how to ensure fairness in the 2 links. In this case, the 2 links in question are a communication between D2D devices, let me see, which is and a communication with the base station and the UE1. Okay, so we want to enable one D2D link and one link between the base station and another UE, and they want to share the same spectrum. Okay. So what we would like to do is to try and ensure some kind of fairness and see what is the maximum throughput possible if you want to enact both these links. Okay? And the ultimate goal, of course, is to extend this framework to multiple D2D links sharing a singular cellular source. This is the work by student Bang Nguyen, and he has a poster outside with a lot of the details. Okay? Now I want to switch to the second topic of this project, which is relays. Okay? So I think the motivation for relays probably is well known to many people, but let me quickly point out what we are trying to do here. One is to, relays can increase the coverage of a cellular system. Okay? So cell edge users particularly can benefit if they're close to a relay. Okay? And so we would like to look at how relays can be incorporated in a cellular system. Okay? And of course, if the UE is close to a relay, it can save on power and also have better quality of service. Okay? And from an operator point of view, the motivation is the lower cost of deployment. Okay? We're also looking at multiple relays. Okay? This is the case where if a source and destination have multiple relays available to them, okay, then you have spatial diversity. And that allows you to now either do some kind of relay selection or advanced cooperative technique to make use of these relays. Okay? So these are relays with advanced cooperation in mind. So here's a typical picture that is used in the context of a cellular structure enhanced by a relay node. So you have a relay node, and these devices will communicate to the base station through the relay node. Okay? And by the fact that they're closer to the relay node, they suffer lower path loss, and so they need to consume less power. Okay? So what are we looking at here? Okay? So there are three groups involved here. One of them is my student, and Professor Kosman and Professor Milstein are involved in the second work, where there are multiple relays being used to enhance communication. And then Professor Javedi and Professor Kim are involved in looking at network and information theory perspective for D2D devices. Okay? I will only touch upon it at a high level, so let me talk about the first one, which is easier for me because this is what one of my students is doing, is really looking at what is the throughput of an OFDMA system that is assisted with a relay, okay? And with partial feedback. So this is a typical OFDMA setup where you're looking at a downlink and all the users provide partial feedback on the quality of the links on the resource blocks. Okay? And you want to ensure fair scheduling. And you can see, for instance, that each user will have different requirements. And particularly the relay, since it's serving more than one user, will probably require more resources. Okay? So for that reason, we look at a weighted CDF-based scheduling. Okay? And this is to provide for fairness, exploit multi-user diversity, as well as being able to allocate a proportional resources based on needs. Okay? So he will show you in his poster analytical results, and results are like, what is the SINR for such a partial feedback system employing the CDF, which are the basis for calculating throughputs. Okay? The second work is by Tu Nguyen, who is working with Professor Kosman and Professor Larry Milstein, and they are looking at a multiple relays assisting a communication between source and destination. So there's a source and a destination, and there are multiple relays in between that can assist this communication. Okay? Of course, when the direct link is available, then the direct link is used. They're actually looking at it at 60 gigahertz, which allows them to use multiple antennas more readily. So each of the source and the relays are equipped with multiple antennas and with directionality. And they know the direction. In other words, they can steer beam towards the source or towards the relay, depending on which link is available. Okay? So in their work, they look at if the direct link is broken, then they use a relay to close the link. And so they look at the throughput of the system as well as the average distortion that the source suffers whenever there's a breakage in these links. Okay? And this is, of course, a function of the number of relays that are available and the probability that a link is broken. Okay? I think I will show you a plot that may be easier to understand. What this shows you is the throughput as a function of number of relays, okay? And the probability that a relay link will fail. That means P0 equal to 1 means the link will certainly fail. Okay? P0.1 means that the probability 10% that the link will fail. Okay? And this is as a function of, let's see, 2 relays, I think, right? Let me see. Maybe Larry, you can help me out. Yeah, I think there are no relay and 1 relay to help in the system. Okay, so no relay and 1 relay. So you can clearly see as soon as you add a relay, you get higher throughput, okay, which is to be expected. Okay? And of course, the relay has less to do as the probability goes down. So if you have P0.1, the relay doesn't significantly increase the throughput. You can look at the same problem by looking at expected distortion, but as a function of number of relays. Okay? So you fix the probability the link will fail and look at it as a function of relays. Of course, as you add more relays, the quality of the link improves, so your expected distortion goes down. Okay? And 2 has more details. So if you go to his poster, he will be happy to share these details with you. And the last topic is work that Professor Kim and Professor Javidi are involved in with their students. This is on looking at an information theoretic perspective of D2D and relay networks. And they are looking at information flooding. They're hoping that there's a common message that will be transmitted over a network, and that means which will be of interest to all the nodes in the network. And so they could relay this information. Okay? And so the goal is to provide a general framework for optimal communication. Okay? So the perspective that they take is a information theoretic approach. Okay? So this picture here, basically you have one node that wants to communicate information to all the nodes. Okay? And all the other nodes could participate by relaying information as necessary. Okay? So the questions, of course, from an information theory point is, what is the fundamental limit on communication? Okay? And which coding scheme, protocol, or architecture achieves that limit? And this is really the question that would be of practical interest. And they look at the problem of broadcast, because Zhang Han tells me that it's easier than unicast or multicast. Okay? So there are several results. Okay? So one of the results, they show that decode and forward is optimal under certain conditions. And these are the 3 cases where they show that the decode and forward is optimal. They show for a simple relay channel, a diamond network, and a layered network. Okay? They also argue that the decode and forward is not optimal in general, and that there are better schemes to use. And they show, for instance, that a partial decode forward and compressed forward can outperform this decode and forward for network with cycles of this kind. Okay? So this is a network with cycles. Okay? And more generally, interactive relaying can outperform anything forward. Okay? This means, I guess this means decode and forward or partial decode and forward. Star means anything forward. Okay? Okay? And relaying basically means that these things can do multiple rounds of interaction between themselves. Okay? Let me close by pointing you the demos and posters that are relevant to this particular project. There's a demo that will show the platform and the D2D emulation. Then there's a poster by Bang Nguyen on the D2D resource sharing, An Nguyen on the weighted CDF scheduling, Tu Nguyen on the 60 gigahertz wireless relay network, and Zhang on information flooding. Okay? So with that, I'll stop, and I'll be happy to answer any questions. Yes.
Thanks, I have 2 questions.
Sure.
The first question is, are you addressing the security aspects for D2D? And the second one is, are the relays you are starting are in-band or out-of-band?
In-band. So the relays are in-band, and the security, the answer is no. Okay. My view on this is, at least if it is useful, then we'll worry about security. Yeah, I bet.
So one simple way of enabling D2D in cellular context is, there are 2 classes of spectrum versus licensed versus unlicensed.
Yeah, yeah.
Cellular operates
In-band, right.
And it is very reasonable to consider for device-to-device use unlicensed spectrum.
Sure.
Say there are a lot of built-in Wi-Fi direct.
Right.
Using that 2 classes of spectrum versus we use the cellular spectrum in-band communication for D2D. What are the advantages or pros and cons?
Yeah. To me, certainly, if the system is heavily loaded, then the operator would be very probably happy to let you use offload, right? So at this point, we are strictly sticking to in-band. Pardon? We're strictly sticking to in-band simply to see how best we can make the reuse, and also it allows us to do these interference management issues. I think the main theoretical ideas will probably have broader implications. The practical question that you ask is clearly that exists. So why would you not want to use some of it? So I would say that depends on how the system is loaded, I would say.
But they're not exclusive, right? You could have the unlicensed communication, but this is,
Yeah.
but we know from theory at least short hops are more efficient, so even if you're only left with in-band.
Yeah, I think then the question would be then the interference questions will change, right? If you decide to include the other option, then you can include that in your system. Yeah.
I see, but that would be in-band, but
No, it will be, if you're going to say Wi-Fi, then it's a different spectrum. Yeah, right. Then you don't have the interference issues to tackle with. Yeah. Yeah, go ahead.
The first part is what you mean by partial decode and forward. What is partial? And secondly is you said the partial is better than just decode and forward.
Yeah.
What about just receiving and forward?
I think you are asking the wrong. I would have a convenient answer for me is you should talk to Young Han and Professor Javidi. Professor Javidi is here. Maybe she may want to answer if you want. Or the poster.
forward, which is what you were saying, is not necessary. So in the cases that they have resolved, and usually must be in the audience. Yeah, so he's there, but I think amplify forward is really suboptimal, at least in those cases, right? Which is what you're asking. And then partial because, why don't you answer this question?
So basically, partial people forward is better than people forward because the relay is not required to for them to be so we can always do a delay shot of it, and then relay the rest. So yeah, so it must be good. I mean, in many cases, it's better than the receive forward, which I mean the amplifier forward,
I think, anyways, he's going to be at the poster, so you can certainly quiz him more. Yeah.
For the relay, in-band relays, have you found an upper bound for the donor node, backhaul network from the donor node to the relay? What kind of spectral efficiency you want to have so that the relay will work? Generally,
Okay.
what we
Yeah,
found that
sure.
the relay doesn't keeps it, for in-band relays, it is very difficult because of the backhaul efficiency.
I was optimistic because I thought the relay node was stationary and the channel between the relay and the base station could be well calibrated. So the quality assurance will be, you have better quality assurance, and power issues are also less of an issue. So maybe we should talk a little to see why is because you have a link, the relay is stationary, right? And so it may have a better channel to the base station.
Because then you need a truck roll too, and then once you have a truck roll, then it gets very expensive. So
When you say truckload, meaning
truck roll,
truck.
truck means somebody has to come and adjust the relay so that you have a good backup.
Okay. And that is expensive. Okay. So your hope is that the relay is just trapped and whatever you get is what you get. Then, then the relay is no longer any benefit. If the relay channel is not very good, the backhaul, then you would not use it. The optimization problem should tell you to go directly to the base station. Pardon?
It should not hurt.
No, it depends on how badly it is positioned, right?
You can ignore it as well.
Yeah, you can ignore it, right? But then you're not getting the benefits of a relay. Yeah,
That's why it never took off.
I see.
The spec is there, everything is there.
I see.
We released it. Never took off.
But it is conceivable that somebody may actually deploy these relays, right? Just like people are deploying femtocells. Not?
There's another issue.
Okay.
Whether you want a close-up
Yeah. But I was thinking these things, whoever is going to deploy them, even though they may not want to spend too much money, wouldn't do such a bad job to the point that it is useless.
I'm going to have to end the session. Going to remind you on the demos coming up and the poster session. Thank you all.